All right, so this is part two of sensory system. And last time, if you remember, we talked about the ear and the different sensations in the ear, including hearing and balance, not just hearing and equilibrium. So now we're doing sight. Sight is the same as vision. We see something, the picture is transferred all the way to the brain, specifically in the back here, the occipital lobe. This is called the visual area. So we will discuss all these details. And the first thing that we need to know, which is this is like basics. You have to know this like very good. It was in the labeling, and it's extremely important. Again, this is the basics of the eye. This is just the parts of the eye. So here is the eye. There are the eye, of course, is a ball like this, and the cover is three layers. We usually do it like this, three layers. The first layer is, look at this white here. This is the outermost or the outer layer. And the outer layer is all of this, all what I'm uh, highlighting right now or showing you. And this is the outer one, and it is two parts from here and even including this part, from here all the way until this point here. This white is called the sclera. The other part is this part in the front, and this is transparent. It's clear. There is no color. If there is anything even white, you won't be able to see. It has to be transparent, and it's from here to here. The rest is the sclera, the white of the eye. If you look in the mirror, you will see this circle in the front. Of course, it is transparent, so through the cornea, you should be able to see what's behind it, which is the colored part of your eye. And this is the next layer, which is the middle layer. But this in the front here is in the cornea. Around it, you will see part of the white, and the white is the sclera, and it is for protection. This part is for protection, the sclera, while this transparent part, which is the cornea, is for refraction. What's refraction? Bending the light rays, because like how your eye, that small eye like this, how can you see like a tree? How can you see a person? A 6 feet person, how can you see him? So the light rays coming from this person or this object, it will travel, and when it goes here to the cornea, it will be bended. So we call that conversion. It will be converted, or it will be bended down to go into the next part, and we will discuss that. I'm just talking about why do we have each one of those. So sclera is for protection and to prevent light from coming in. Cornea is to permit the light to go in, and refraction, bending the light rays. The second layer, it's called the middle layer or the vascular layer, and it consists of several parts. Look at this right here. It's kind of orange, reddish orange. This is right under the white, so this is called the choroid. And here it is all the way until here. Then there will be an expansion here. This expansion right here, when you see the cursor, this is called the ciliary body containing the ciliary muscles, a body containing muscles. From this body that contain the muscles, there are, look at these fibers here. It's called suspensory ligaments because it's going to suspend this lens. It's convex. Look here and here, this white. Of course, it's not white. It is actually transparent as well. In front of that, also coming from here, this is the iris. And the iris is the colored, which is, look at this picture here, the colored part of your eye. When you say like my eye is black, brown, green, blue, whatever it is, you're actually talking about the iris. This partition here, colored, and it is not a complete partition. There is an opening in the middle of this partition here, or this iris, which is the opening is called the pupil. The pupil. So second layer again, it's called the middle layer, choroid, ciliary body with ciliary muscles, suspensory ligaments, lenses attached to it. In the front of it is the iris. In the middle of the iris, there is a pupil, which is just a circular opening. The last layer, the third one, is the innermost, which is this yellow here. It's kind of orange yellow. And this will be the retina. And the retina, which is this orange yellow, is the one that contain the photoreceptors. And we will discuss the photoreceptors. It's all over this, and there are different parts, except this part right here. So like here and all over the retina, there are photoreceptors. From these photoreceptors, and the photoreceptors are connected through nerve fibers, and these nerve fibers will exit from here. So since this is like a door or a window through which the fibers coming from the photoreceptors exit, it exits from here. So there are no photoreceptors in this area here. What is this circle right here? Right here. This is called the optic disc, because optic nerve will start from here. What's the optic nerve? Optic nerve is the fibers coming from the photoreceptors coming together to make the optic nerve. So like you can say it like this. In the wall of your house, there are a lot of bricks. But do you have bricks in your door? No. Do you have bricks in your window? No. The bricks are like the receptors. So the receptors are all over except the door. The door is for you to exit out. So there are no bricks. Same thing here. This is the exit here. This is the beginning of the optic nerve. There are no receptors. It's called the optic disc, but because there are no receptors, we also call it blind spot. Blind spot. Why did you call it blind spot? No photoreceptors. In order to see, you need the photoreceptors. There are no photoreceptors. So what do you call this? Optic disc and blind spot. This is the exit out of the fibers coming from the receptors. Together, it will make the optic nerve. And look at the sclera. The sclera will extend and cover the optic nerve as well. Look at this white extending in the back here. Okay, another thing that we need to know is beside the optic disc, there is an area right here. Look at this, it's a fovea, this part. It's a spot in the retina that is heavily clustered. I know that the photoreceptors are scattered in the inner layer, which is the retina. But specifically, this part is heavily clustered. It contains huge amount of these receptors. So we want it, when you see something, we want it, the picture to be converging, refracted to go to specifically this point so that you have the best vision. If it goes somewhere else, it will be blurred vision. You don't see much. But we want it to be in this fovea called fovea centralis because it is heavily clustered, specifically one type of photoreceptors. We will discuss the photoreceptors, but there are two types, rods and cones. Rods and cones. Cones are the one for day vision and color vision. This is heavily clustered with photoreceptors called cones. The other thing that I want you to know is this ball right here, this whole thing here, is not one cavity. It is two. It's divided into two. Divided by what? Divided by this, the lens. There is a huge cavity behind it, a big one behind it, and a smaller one in front of it. The back one, posterior cavity, of course, it's not empty, it's not air, otherwise the eye will collapse. It's filled, but filled with something called, look at this here, it's called the vitreous humor. It's gel or jelly-like. So it is filling this posterior big cavity. How about in front of the lens? The small one. Yes, the small one is called the anterior cavity. And the anterior cavity contain aqueous humor. Is it the same? No, it's not the same. Aqueous is coming from aqua, which is water. So the fluid here filling the anterior cavity is called aqueous humor, which is this part. So again, there is a small anterior cavity filled with aqueous humor. What do you mean anterior cavity? Anterior to the lens. Filled with aqueous humor, watery. How about the posterior cavity? Posterior to the lens. It's filled with vitreous humor, jelly-like or jello-like. So here is what I was talking about. If you see something, the light rays will go into your cornea, and look what's the cornea doing? It will bend it. It will bend it so that it can pass through this opening here, which is the pupil, and then reach the lens. In the lens, you will be doing another refraction or bending of the light. So you bend it more. Look at this. You will bend it until it goes to this part right here specifically, which is the fovea, which is your focus point. The fovea is heavily clustered with cones. The cones are, or cones, it means cones. The cones are the photoreceptors for day vision or color vision. And to remember it, C, remind you with the C. Cons, color, which is day. Of course, you see everything during the day colorful. In the nighttime, if it's dark, you can barely see black and white. And these are the other photoreceptors called rods. And this is important to know. But the point I'm trying to make here is you will do refraction or bending of the light twice. One through the cornea, which is transparent, and the next through the lens, which is also transparent. If the cornea is not transparent, if the lens is not transparent, you won't be able to see. You will not be able to see everything from the object all the way until you reach the fovea. Everything is transparent, colorless. There is nothing on your way. If there is something, you will not be able to see. Now, is it different when I have like my cell phone like this, if I have it here versus if I get it closer to my eyes? Yes, of course. Why? Because when I hold it like here, the light rays will come, it will be refracted through the cornea, and that doesn't change. And then it will be refracted or bended again in the lens. But if I get it closer, now you need more bending because the object is closer and it's bigger. Of course, it looks bigger now. So you have to bend it even more. How to bend it more? Yes, you can change the shape of the lens. If you do it like this, by relaxing these muscles, this will do more bending, and we call that accommodation. So what's accommodation? Adjusting the lens shape according to how close the object to your eye. If you hold it and you like move it away like this, and then you get it closer, the lens is going to change the shape to accommodate it. If you get it closer, it will change the shape again and accommodate it, which will be doing more bending. So if you relax, look at these muscles here, the ciliary muscles. connected to these suspensory ligament or the fiber slack right here, suspending the lens. If you relax it, look how the lens look like now, more convex. So now that will allow you to see closer objects because there will be more bending. If you move something away, you will contract the muscles. So look at this convexity. It's less. Compare this convexity to this. Closer is more convexity by relaxing your muscles. If you're looking at something that's distant, the muscles contract and the convexity become less, so less refraction or less bending. Some people will have um, an issue. This is very common, obviously, that they need glasses or corrective lenses. What does it mean? It means, and I'm not going through into the details, but only if you guys are interested to know, look at this picture right here and think about it. Some people will have this eyeball a little bit bigger, a little bit bigger. So if it's a little bit bigger, that when you see something, the light rays will go here and it will be reflected or refractory refraction will happen and it will the picture will be here, not on the retina, not on the fovea. It will be in front of it because it's bigger. Look at this here. So if the picture goes like this, it should go all the way to the back here to the fovea. If this is bigger, it will go all the way in front of it. You will not be able to see clearly. We call that near vision, and you need corrective glasses in order to help you get the refraction in the right spot. And the other way around, if your eye is smaller, this refraction will happen behind the retina. So you can use either it's called corrective lenses, whether it is glasses like this or it can be lenses, whatever glasses or lenses, whatever that can help you to do the refraction. If you guys are interested to know more information about anything, I can tell you, but I'll be focusing, generally speaking, on the core of the chapter as usual. Um, in the eye, the outer layer, what do we have that's curved? Cornea is curved because it's curved and it cover the iris, which is this cornea, curved and covering this. This is the iris, the colored part of your eye. The middle layer is called choroid. And this area will contain blood vessels, and it will prevent the light from coming from different sources. So it's like this. Look at this. This is the outermost, which is the sclera, under which you have the choroid. The choroid contain blood vessels to feed the other layers, plus it's dark. So light rays cannot come from here or here or here. It has to come only from here to the cornea. Otherwise, it's prevented by the presence of uh, the choroid. Um, and that will enable us that the light rays goes through the cornea and it will pass through the pupil, go to the lens, and the lens will focus the light. What's focus the light? Focusing it, bending it, refraction. So it focus the light, it bend it. So it goes exactly in the point that's needed. Photoreception occur in which layer? the outer or the middle or the inner. It's the inner one called retina. And in order to go to the retina, the adjustment will happen through the lens, depending on how close or how far the object. Now, what I want, these are the photoreceptors. Look at this. It looks like a rod shaped, and this looks like a cone shaped. So these are called the rods and the cones, or cones. There are two different cones. This is English cones. This is Greek, but rods and cones. Let's say rods and cones, and this is important to know. And what I want you to know here is rods is for dim light or night time. So it's black and white. You need to remember this. Rods for night vision, dim light. So you see what? I see black and white. How about cones? C, remind you with the C. Cones, color. Cones, color. Do you see the color during night, during the day? During the day. So the cones are responsible for what? Daytime, light, color. Cones, color. C, cones, color. When do we see the color? Of course, during the day. If you have bright light. If it is dark, you can't see the colors. So remember those two types of photoreceptors. Again, this is very important. It's basics. So the light rays contain energy that goes in different waves, and it will make different colors starting from the red, ending at violet. And that's why under the red, we don't see it. They call it infrared. Infra means under. Violet, above the violet, is called ultraviolet. Of course, you don't see the ultraviolet and the infrared because this is our range, starting from red to violet, passing through all of these colors: orange, yellow, green, blue, indigo, or something in between the blue and the violet. And the maximum that you can see is violet. Above it, no. Above the violet, which is ultraviolet, no. Under the red, no. Um, Here is an interesting piece of information. These rods, of course, it's responsible for night vision, and it is black and white. So it contains a protein and or a pigment, and this pigment, in order to maintain it, you need vitamin A. I don't want to go through into much details. It's called the retinal and retinol. It's a lot of details, but what I want you to know here is the pigment that help the rods to work is coming from vitamin A. And that explained, if you ever heard of it. If you have vitamin A deficiency, you have night blindness. You don't see much during the nighttime because you don't have vitamin A, you have vitamin A deficiency. So the pigment that help these rods to work is not efficient, or you don't have enough of it. Cons, on the other hand, contain another protein called opsin, but that's okay. What's after that? What's after, like the retina here contain photoreceptors, and from the photoreceptors, there are fibers that leave, and it will make the optic nerve. What's after the optic nerve? Optic nerve from the right eye and from the left eye, they are going to cross one side from this and the other side from this. They are going to cross. Cross in Greek is called chiasm. So this is optic nerve and this is optic chiasm. After the optic chiasm, you have the optic tract. That will take it to something called lateral geniculate body, and it will go all the way to the visual cortex. But what we need to remember here is what's after the photoreceptors in the retina: optic nerve, optic chiasm, optic tract, and then the visual cortex. Where's the visual cortex? Here, occipital lobe in the back. So here it is, rods and cones are in the retina. These are the photoreceptors. Which one is responsible for dim light, which is black and white? These are the rods. Which one for bright light and color, daytime? These are the cones. And cis retinal and all that stuff, that's okay. I mean, it's more details, but I told you what you have to know. Okay, so that's it for this part. And the rest is only if you are interested to know. It's more of a lab, and these are different conditions. I'm not going to ask you about it. It's more advanced for our course. So if you're interested, color blindness is you cannot see like one or more colors, something like this. I can ask you, what's a number here? You say there is no number. It means you have an issue with the red, and so on. It can be one or more color blindness. Astigmatism, cataract, myopia, hypermetropia, conjunctivitis, glaucoma, cancer. These are all different types of issues. Color blindness can be red, green. There is something called night blindness, which is vitamin A deficiency that I talked about. Why? Because you don't have enough to make the pigment for the rods. That's it. Astigmatism is the cornea is not smooth. Myopia or nearsightedness. This is you're wearing this again. This is just if you're interested. There is nothing much, and I'm not going to ask you about this. The last thing that will ask you about is this, the receptors. Anything else? Only if you're interested to know and for yourself. This is too much for the purpose of this course. So only if you're interested to know. Nearsightedness, it's called myopia, and this is where um, your eye is a little bit bigger. It's nobody can actually see it. Like if I show it to you, you will not say, "Oh, this eye is big." No, it's just very tiny bit, just a little bit bigger. So if that the case, the bending of the light, the focus will fall in front of the retina. So if you wear glasses or lenses, it will correct it. Farsightedness is the opposite. You can't see something um, that's far. So it's depend on the size of the eyeball and the curvature of the cornea. But anyway, these are different things that can be corrected with lenses or glasses. Here it is. This is what I was talking about. It can fall in the front here. This is abnormal. It can fall behind it. This is abnormal. It should fall exactly right here in the retina. If it fall here, you wear glasses or lenses to correct it, and it will end up falling here. Of course, you have to get the correct uh, lens or the correct glasses. It's of course it needs measurement, and you guys know that. Look at this picture here. And if it fall like not exactly here, you will see something like vague like this versus this. Again, this is only if you're interested. Conjunctivitis, there is something covering the white of the eye that's called the conjunctiva. I don't think I talked about this. The conjunctiva, remember the white of the eye, the outermost, the sclera. It is covered by another layer that's called conjunctiva. And this conjunctiva is, if you look in the mirror, you will see the white and you will see some like vessels, tiny vessels going through it. This is not actually in the sclera. This is in the cover of the outside of the sclera called conjunctiva. Can be infected. We call it conjunctivitis. Like if you see secretions like that, it doesn't have to be that bad, but even if you see a little bit and you see congestion, the conjunctiva, which is this outer layer that's outside of the sclera, is infected. Trachoma is infection, herpes is infection, melanoma is cancer. It can happen in the eye, actually. Retinoblastoma is a cancer. Cataract, the lens, I told you, it should be transparent. If it is not, we call that cataract. And it will, if it's not transparent, it will be kind of cloudy, so you will not be able to see. If that's the case, they used to get rid of the lens and give you glasses. They don't do that anymore. They take the core that's bad and get rid of it, and they put the insert a replacement. Most likely they get it from pigs. Sometimes they get it from donation from somebody died or whatever, but the pig is compatible. So they can actually insert it, or they can put something artificial or something that's they make in the lab. But anyway, the idea is both the cornea and the lens has to be transparent. If it is not, you will not be able to see. If the lens is not transparent, if it's cloudy, we call it cataract. Macular degeneration, it's an issue in the macula in which there is a fovea. If somebody's having cataract, the vision will be like this. Macular degeneration. Glaucoma, remember I told you that the eyeball is not empty. It does not contain air. It's not empty. The anterior cavity contain aqueous humor, and the posterior contain vitreous humor. Remember? The vitreous, the jelly-like. The front is aqueous humor, the watery. If the pressure of that aqueous humor increase, we call that glaucoma or blue eye, if you ever heard of it. Again, all these abnormalities is just uh, if you're interested to know. And here is a summary of these. We talked about it already, starting from the nervous system with the different sensations and receptors, and then the special senses, including taste and smell with the chemoreceptors, hearing, the different parts of the ear, and then uh, including hearing and balance, and then the eye with the different parts and the photoreceptors, and that's it. So let me stop here.